Hello student, I am Dr. Sinha. I will continue from the last class what I have discussed. Now I am going to discuss laws of chemical combination. The combination of elements to form compounds is governed by 5 basic laws. First law is law of conservation of mass. What is this law? It states that matter can neither be created nor destroyed. This law was put forth by Antoine Lavoisier in 1789. He is also called father of chemistry. Now, second law, that is law of definite proportion. This law was given by a French chemist, Joseph Prost. He stated that a given compound always contains exactly the same proportion of elements by weight. Porus worked with 2 samples of cupric carbonate, one of which was of natural origin and the other was synthetic one. He found that the composition of elements present in it was same for both the samples. As for example, natural sample in the compound or in the molecule, percentage of copper was 51% and percentage of oxygen was 9.74%. And in synthetic sample 51.35% and oxygen 9.74%. Means if you will add both, it will become 100%. Means natural sample 51.35 plus 9.74%, 100%. And by synthetic method, that is in synthetic sample, it was found same way, 51.35 plus 9.74, means 51.35% was copper and oxygen percentage was 9.74%. Means according to the Prost, 2 sample of cupric carbonate, one of which was of natural origin and other was synthetic. He found that composition of elements present in it was same. And just now I give an example of natural sample of cupric carbonate. Then carbonate percentage was also found same, 38.91%. Means percentage of copper 51.35 and percentage of oxygen 9.74% and percentage of carbon 35.91, and it formed cupric nitrate by 2 method or by in 2 samples, natural sample and synthetic sample. This is the example of, we can say, law of definite proportion. Now I am going to discuss another law, that is the law of multiple proportion. This law was proposed by Dalton in 1803. According to this law, if two elements can combine to form more than one compound, the masses of one element that combined with a fixed mass of other element are in the ratio of a small whole number. Again, I am repeating, if two elements can combine to form more than one compound, the masses of one element that combined with a fixed mass of other element are in the ratio of a small whole numbers. For example, hydrogen combined with oxygen to form two compounds. What are the two compounds? It can form water and it can form hydrogen peroxide also. Then here hydrogen 2 gram and oxygen 16 gram. If both will react, means both will mix 2 gram hydrogen, 16 gram hydrogen, then it will form 18 gram water. Second, again 2 gram hydrogen, if we will mix with more oxygen, that is 32 gram oxygen, it will form 34 gram hydrogen peroxide. 34 gram hydrogen peroxide. Here the masses of oxygen, that is the 16 gram and 32 gram, which combined with a fixed mass of hydrogen, that is the 2 gram, bear a simple ratio, that is a 16 is to 32, that is 1 is to 2. This is called law of multiple proportions. Now, third one, Gail-Lujak's law of gaseous volume. He has given importance of volume during the reaction. This law was governed by Gail-Lujak in 1808. This law was given by Gail-Lujak in 1808. He observed that when gases combine or are produced during the reaction, in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at the same temperature and pressure. This is the actually Gail-Lujak's law of gaseous volume. Example, suppose 100 ml of hydrogen combined with 50 ml of oxygen to give 100 ml of water, means hydrogen 100 ml plus oxygen 50 ml, and it will give after the reaction water. How much? It will give 100 ml. Thus, the volume of hydrogen and oxygen which combine together, that is 100 ml and 50 ml, bear a simple ratio of 2:1. Gail-Lujak's discovery of integer ratio in volume relationship is actually the law of definite proportion by volume. Earlier what I have discussed, that was with respect of mass, but this is with respect to volume. Gail-Lujak's law of gaseous volume, its name itself is there. One should not confuse with earlier one. That was related to mass, with respect of mass. But Gail-Lujak's is related, discovery or law is related to volume. Now, I am going to discuss Avogadro Law. In 1811, Avogadro, popular scientist, chemist, Avogadro proposed that equal volumes of gases at the same temperature and pressure should contain equal number of molecules, and it was found so also. Avogadro made a distinction, means difference between atoms and molecules. This is Avogadro's law. Any gases, according to him, any gases Avogadro proposed, it was the proposal and that became the true, proposed that equal volume of gases, any gases, 2 gases, 3 gases, 4 gases, condition was there at the same temperature and pressure should contain equal number of molecules, and it proved correctly. Avogadro made a distinction, means difference between atoms and molecules. This is, I told about the Avogadro law. Actually, this in the beginning, it was Dalton, particularly Dalton, and that time others believed that that atoms of the same kind cannot combine, means H and H can't combine, O and O can't combine. But later on it was proved wrong. They can combine, H and H can combine, O and O can combine, means H and plus H, H2, O plus O, O2. But that time Dalton particularly told that they can't combine. Same atom, they can't combine themselves. But later on it was proved wrong. Now I have told all 5's law. Now I am going to discuss Dalton's atomic theory. Dalton given a theory, that time it became popular. Now what was actually its theory? Then in 1808 Dalton published a new system of chemical philosophy, means theory. What was its theory? What was his proposal? What he proposed? Then I am telling he has proposed 4 points. What are that? Then first point he told that matter consists of indivisible atoms. Already I told indivisibles means it can't be divided further. This statement is given by Dalton. Matter consists of indivisible atoms, means any matter is made from the atoms. Atom already told you that is in the beginning it was considered indivisible, but later on it was proved that it consists of electron, proton and neutron. Then here Dalton told matters consist of indivisible atoms, means by mixing atoms molecule is formed, by addition of atoms, by combination of atoms matter formed. This is the first point. Second point, what he told, all the atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. This is the second point. Third point, what he told, compounds are found When compounds are formed, when atoms of different elements combine in a fixed ratio. If atoms are different type of atoms are there, then they will combine in a fixed ratio. Next point, fourth point, that chemical reactions involve reorganization. In chemical reaction, reorganization of atoms takes place. Chemical reaction involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. What was in the beginning, all will react and will give product, new things. No destruction of the reactants. What was that? In the beginning, all things will convert into the product. That's why chemical reaction involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. Dalton theory can explain the laws of chemical combination. This is the importance of Dalton's atomic theory. Now, I am going to discuss about the atomic mass. Already I have told about some things I told about the atom. Now I am focusing on atomic mass, particularly about the atomic mass. Mass of one atom, that is called atomic mass, and it is measured in atomic mass unit, AMU. All things I have discussed, and I don't want to repeat here. And now these things I want to go ahead. I told you that it is measured in atomic mass unit, AMU. AMU is defined as a mass exactly equal to 1/12 of the mass of one carbon. Carbon, you know that, has three isotopes, C12, C13, C14. It is found in three form, C12, C13, C14. Here, standard is considered as 12, means carbon 12, three isotopes I told you. Then first isotope, which is found in you can say large quantity, 98% roughly, carbon 12 is found. That's why it is considered as a standard. Then one atomic mass unit is defined as a mass exactly equal to 1/12, 1 divided by 12th, the mass of one carbon, 12 atom. One carbon means C12 atom, 1 divided by 12th of C12 atom. And one AMU, that is equal to 1.66056 into 10 to the power minus 24 gram. Mass of an atom of hydrogen, that is a 1.6736 into 10 to the power minus 24 gram. It looks same, 10 to the power minus 24, 10 to the power minus 24. But where they are differing? They are differing very slightly. One AMU, I told you 1.66056. But for hydrogen, What is the mass? 1.6736 into 10 to the power minus 24 gram. Minus 10 to the power minus 24 gram is common. Thus, in terms of AMU, the mass, how will it come to? Mass of hydrogen atom will be, just to divide it means 1.6736 into 10 to the power minus 24 gram divided by 1.66056 into 10 to the power minus 24 gram. Means you are dividing by AMU. Upside is hydrogen, mass of hydrogen, and down is just you are dividing by the value of AMU. Then its value comes after division, its values comes 1.0078 AMU. Then mass of hydrogen in term of AMU is 1.0078 AMU. Roughly you can tell 1.0080 AMU. Similarly, the mass of oxygen 16 atom should be, after division it will come 15.995 AMU. 15.995 AMU. Then I have calculated, or I told you, mass of hydrogen and mass of oxygen in terms of AMU. Now I am going to discuss about the average atomic mass. Average atomic mass. Actually, atomic mass, how will you come to know? Every atom has their own mass. In periodic table, one periodic table is there. I will show you, and I will also give you. In that you can find that now 118 elements are there. 118 elements are till date it is found, and these elements are grouped in, you can say, divided into so many groups, like group 1 to group 18, and each group has a meaning. Whole periodic table that is divided into the group and periods. Horizontally it is called period, and vertically it is called group. Then in chart, I will provide you chart, you can see in video, and in that there some things, important things is written. As for example, there it is written symbol of elements. As for example, hydrogen, H will be written. For helium, He will be written. For sodium, Na will be written. Potassium, K will be written. Like that way, 118 roughly, I am telling you, 118 elements are now discovered, and all 118s, in that someone is not found, but it is 100% it is sure that it will be found in near future. That also will come out, because this atomic number, like as for example 118, that is found, that atom is found, but in the middle few elements are not found, but it is expected that that is there, that also in future that elements will be found. For that some blank is kept. Then here in periodic table you might have seen also that all elements are grouped, and horizontally it is called period. Horizontally arrangement is called period, and in a group way it is called vertically it is called group. And if you will see the periodic table, it will found that in different color, different groups elements are shown in different color, that you can find. If you will see, you will watch, you will observe the periodic table, they will find that elements are grouped in different, you can say they are shown in a different color. They are shown in a different color in a group, different group, different color, and they have a special characteristics also. Okay, and there in periodic table you will find that it is a written symbol of the element, and after that atomic number is written. Already discussed, atomic number is the number of electron, that is equal to number of proton, that is called atomic number. That number will be written, and down atomic mass will be written. Then every atom, or you can tell every element, have different atomic number and different you can say atomic mass, atomic weight, also called atomic weight. For each atom, different atomic number is there. Fixed atomic number for one atom, fixed atomic mass is there, and atomic number is also fixed. Atomic mass, which is also called atomic weight, is fixed for each element. Means for 118 elements, every atom has different atomic number and different mass number, which is also called atomic weight. Okay, this is very important, because this atomic mass you will need in calculation time. Okay, then now I want to discuss about the average atomic weight. What is this average atomic weight or average atomic mass? By example, I want to clear it. Suppose you consider carbon. Already I told you, carbon has 3 isotopes. Isotopes means atomic number will be the same, but atomic mass will differ. Atomic number will be the same, but atomic mass that will differ, means proton plus neutron, their number will differ. Then here I am telling you that carbon 12, carbon 13, carbon 14, how much it is found? Actually they are not found in the same percentage, all found in different percentage. Relative abundance, I am telling you, relative abundance, that is the C12, that is found in its percentage is 98.892 percentage, 98.892, and 13, its percentage is very less, 1.108%, and 14, carbon 14, its percentage is very less, that is the 2 into 10 to the power minus 10. This is the percentage of abundance, relative abundance, also called relative abundance. And atomic mass in unit for C12, that is the 12. For C13, it is 13.00335, and for 14, 14.00317. Here I want to tell you important things, that C14 is radioactive. Radioactive. This is very, very important information I am telling you. Now, how will you calculate? How will you calculate average atomic mass of carbon? I am giving example to calculate average atomic mass of carbon. Then it is very easy to calculate. Just I am explaining you. This is the 98, C12 is 98.892%. Then this 98% is of what? Then 98.892% of 12. That is the atomic mass of carbon in AMU. That is a 12. Then 98%, 98.892% of 12 plus C13 is there. Then its percentage is very less, 1%, 1.108%. Then 1.108% of 13.00335. That is the atomic mass of carbon 13. Atomic mass is 13.00336. Then 1.108% of this 13.00335. Like that way, third one, carbon 14. Then same way, 2 into 10 to the power minus 10%, very, very less. That percentage of 14.00317. 2.2 into 10 to the power minus 10 percentage of atomic mass of carbon 14. Then after that you add all three, means 98.892 into 12. Actually you can convert it in the 98%. You can write 98 divided by 100 means 0.98, like that way. All three same way. 1% means 1 divided by 100. Like that way. 2% means 2 divided by 100. Then 198 divided by 100 into 12 plus 1.108 divided by 100 into 13.00335 plus 2 into 10 to the power minus 10 divided by 100 into 14. All three you add, then you will get average atomic mass. Correct? How to calculate average atomic mass is very easy to calculate. Means multiply the percentage of all three with their atomic mass. Simply 98% into 12 plus 1% into 13 plus 2 into 10 to the power minus 10 divided by 100 into 14, and you add it. Whatever value will come, actually its value will come after doing all the things, it will come 12.011 unit. Okay, this is how we will calculate average atomic mass. I have told you. Similarly, actually you can calculate for any other atom which have, you can say, these things, different isotopes. Oxygen also have different isotopes, sulfur also have different isotopes. Then if different isotopes are found, then their average atomic mass you can calculate in this way. Means very simple way, percentage of abundance into a atomic mass of that isotope. That 3 isotopes I told you, then each isotope a atomic mass. Just simply multiply percentage of abundance into atomic mass of that isotope and add all 3. If isotopes are found only 2, then add only 2. If it is found 4, then all 4 you add. That is called average atomic mass. This is actually important, and its value will come in point. That is called atomic weight. But mass number, that is always it will be whole number. Mass number is actually, this is the I can say addition of proton plus neutron. If you will add the number of proton plus number of neutron, then it will give whole number. It is a whole number, that is the mass number. Actually, I told you atomic mass, average atomic mass. Then average atomic mass, that is also called atomic weight, that is in fraction. But mass number is always whole number, which is sum of proton plus neutron of that atom. Now I want to tell you that how to calculate molecular mass. What is actually molecular mass? Then it is also very easy to understand. Molecular mass is the sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by the number of its atoms and adding them together. For example, molecular mass of methane, which contains 1 carbon and 4 hydrogen atom, CH4. Methane, it is represented as CH4. Then here 1 carbon and 4 hydrogen. Then what will be the molecular mass? Then very easy. Atomic mass of carbon plus atomic mass of hydrogen. Here 4 hydrogens are there. Then 4 into 1.008. 1 atomic mass of hydrogen, you know, already I told you that 1.008. Then 4 hydrogens are there. Then 4 into 1.008 plus 1 carbon is there. Then 12. Then add it both. 12 plus 4 into 1.008. 1.008 roughly you can tell 1 only. Then 12 plus 4, that is the 16. 16 is the molecular mass of methane. Like that way you can calculate for any molecule. Oxygen O2, then 2 into O, then 1 O, you know that is the 16. They say 2 oxygens are there. Then 1 oxygen atomic mass is 16. Then O2 means 16 into 2, that is the 32. Like that way, chlorine also you can calculate. Cl2, 2 into Cl, or Cl plus Cl also you can tell. Then Cl atomic mass is 35.5. Then 35.5 plus 35.5, that is equal to 71. That is the molecular mass of chlorine. Like that way you can calculate for you can say glucose also. Glucose, that is a H12O6. This is the formula for glucose. C6H12O6. Then here you can see 6 carbons are there, means 6 into carbon plus 12 hydrogens are there, then 12 into hydrogen, 1 hydrogen plus O6, then C6H12O6, again 6 into oxygen, 1 oxygen. Then you know that for carbon their atomic mass is 12, then 6 into 12 plus hydrogen 1 into 12 plus oxygen 6 into 16. 6 into 16. If you add all the things, after multiplying you will add, you will get 180. Exactly it will come. If you write all the exact value for hydrogen as for example 1.008 and for oxygen 15.99 something, exactly if you write, then its value will come 180.162. 180.162 gram or unit you can write. Then now I told you that how to calculate molecular mass. Same way it is very easy to calculate molecular mass. Generally for organic compound means compound which contain carbon. Carbon is essentially, that is called organic compound. Organic compound, carbon is must. Then molecular mass for organic compound you can calculate. Now I have told you for how to calculate for these things, glucose or any other compound. Same way you can calculate. But here one more term is there, that is called formula mass or formula weight. Formula mass or formula weight. What is this actually? Then this formula mass is used for if you want to calculate formula mass, then this formula mass is used for ionic compounds. For ionic compounds, as for example NaCl, sodium chloride, Na plus Cl minus. Actually we will discuss about the ions separately, but here I am telling you how ions are formed from the neutral atom. From the neutral atom, in outermost orbit electrons will be there. If it will come out or it will give its outermost electron to the other, suppose 1 electron it has given, then it will acquire 1 plus. As for example hydrogen, outermost orbit 1 electron is there and it has given to the others needy, as for example to chlorine, then hydrogen will be written as H plus. Sodium again, if it will give 1 electron to the others, it will be written as Na plus. Like that way, potassium K plus, then H plus, Na plus, K plus, these are called cation. Ion, this is called ion and positive charge is called cation. Similarly, other elements who have taken the electron, as for example chlorine has taken 1 electron, then it will be called Cl minus. Bromine suppose has taken, then bromine 1 minus. Fluorine has taken, then fluorine 1 minus. 1 minus means here they have taken 1 electron, and this negative charge is called anion. Then cation, positively charged ion is called cation and negatively charged ion is called anion. Then here in sodium chloride, you know that the positive charge and negative charge will attract to each other. Hence molecule is formed. NaCl. It will form NaCl. This is called actually ionic molecule. Ionic molecule. This is also molecule, but ionic because positive charge is there. Positive charge or negative charge is there. That's why it is called ionic salt. Also called salt. Salt means always positive and negative charge. If you will dissolve in water, it will a separate sodium ion will be separate, chloride ion will separate. Then here formula mass means you are going to calculate that just like a molecular mass. Here you are going to add sodium ion mass plus chloride ion mass. As for example, sodium, its sodium ion, its mass, atomic mass is 23 and chlorine 35.5. Add both 23 plus 35.5, 58.5. That is called formula mass. Formula mass is used, it is just like a molecular mass, but it is especially used for ionic compound, ionic molecule. This is the difference between the both. Okay, that this is used especially, formula mass is used especially for ionic molecule. Okay, now you can same way you can calculate formula mass for other ionic compound, because actually this is a simple one. You are calculating for one unit only, and that's why here it will exist in the ionic form, sodium ion, chloride ion, like that way. Then just simply you add you can say atomic mass of sodium, atomic mass of chlorine, chloride ion and sodium ion, chloride ion, 23 plus 35.5